All right, here's a good question. You are asked to find, after 20 minutes, what will the temperature of the coffee be? So here's our formula. So the temperature after a given amount of time is equal to T0, which is the surroundings temperature. Surroundings, okay? Plus T1, which is the coffee temperature, okay? Minus T0, that's the surroundings again, e to the minus k and t. Okay, initially they say a cup of coffee is at this. They put it in the surroundings of that, and after this time, the temperature comes down to 36. And what I need to do is use all that information to determine what the degree of cooling is. So there's some kind of factor that things cool down by, and I have to figure that out first. Then I'll get to this 20-minute question. Okay, so the final temperature of the thing was 36. So that's the number that goes in here. 36 is equal to temperature of the surroundings. It's in the freezer, so it's 0. Good. Oh, that's an easy one. Plus temperature of the coffee initially, 120. Minus the temperature of the surroundings, 0. E to the minus k, which I don't know. And all that happens in 15 minutes. There we go. Okay, so I can subtract 0 from each side. Of course, that doesn't change anything. 120 minus 0 is just 120. E to the minus k times 15. Divide, I want to isolate this part, so divide both sides by 320. So we'll get 36 over 120 is equal to e to the minus k times 15. Okay, so I've got a variable in the exponent, so I'll change it to log form. So log base e of whatever 36 over 120 is equal to negative k times 15. So to figure out what k is, now I'll just divide this side by negative 15 and divide this side by negative 15. Okay, so I'll do k over here. K is equal to, let me bring in a calculator. Whoops, that's not how I do it. Here we go. Okay, calculator. So log base e is the same as ln, right? So ln, where's ln? Ln of 36 over 120. 36 divide 120. Okay, and then close that bracket. And now I want to divide that by negative 15. Negative 15. There we go. So my k value up there, I'll just put it here on the side. So k then is equal to 0.08026,485, etc. Okay, so now, that was my k value. So now what I'd like to do is to use that k value to figure out what the temperature of the coffee is going to be after 20 minutes. Let's do this in blue. I'll use the same formula. So the temperature after 15 minutes is equal to the surroundings, it didn't change, plus, and the coffee, it started at 120. Whoops. This was 0. So the surrounding was at 0, plus 120 minus 0. Good. E to the minus, now k I know is 0.08026,485, etc., times the time. This time they say, what's the temperature after 20 minutes? So I'll put a 20 there. Now this one I'll just simplify just a little bit. The 0 plus won't change anything. 120 minus 0 is 120, so it'll be 120 e to the negative 0.08026,485 times 20. And I like to use a lot of that stuff in there when I'm doing the calculator. Okay, let's go to the calculator and see what we come up with. Now, can I use any of that stuff that I have there? I don't know how to do that well in decimals yet, so I'll just do it as is. So 120, whoops, 120, and then E. I think I can just go to ABC, and when I hit an E there, I think that, well, the calculator does know what I'm talking about. So 120E to the, that's that button, negative 0.08026. Notice as I keep typing numbers, 485. That number down below doesn't change much. And I have to times that by 20. Uh-oh, that went down. I don't want that to go down. How do I get it to stay up there? Put a bracket. Oh yeah, there we go. Times 20. Let me check to make sure everything looks right. I think so. So 24.0999. So let's see what the question is. So 24.099587, etc. Okay, so the question says to the nearest integer. So the nearest integer I would say is just 24. And I think that's sort of what was, I think that was the correct answer. All right, hopefully that helps you with the coffee in the freezer question. Who would put their coffee in the freezer? I guess to cool it off a little bit.